Part one of our nomenclature journey is going to be looking at binary covalent nomenclature. So covalent, again, we're dealing with nonmetals here. Binary meaning that each of the compounds that we are going to look at is only going to be composed of two different types of atoms. Okay, so our covalent nomenclature, basically what we do is we take a prefix denoting the number of the first element, a prefix denoting the number of the second element, and we change the ending to IDE. Okay? If there's only one of the first element, we don't use a prefix. So when we only have one of the second element, though, we still use a prefix. So a couple examples here: carbon dioxide. So di is a prefix for two. Tribromine octoxide, tri being a prefix for 3, octo being a prefix for 8. Okay, so these are our prefixes. Okay, we have mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Okay, so again, if we only have one of the first element, we don't have a prefix there. We only use mono for the second element. The other note is when we're dealing with oxygen. So oxygen, it's interesting. We only do this for oxygen, but when we have a prefix that ends in O or A, we end up dropping the O or the A when it's next to oxygen. Okay, so we don't drop any of the other vowels, and we don't drop anything for any other element. It's just for oxygen, we end up dropping the O or the A in the prefix next to oxygen. So that's why it was octoxide, not octooxide. If I have 5 oxygens, it would be pentoxide, not pentaoxide. So it's just the convention that's being used. Okay. Again, mono we only use for the second element. So here's some examples. If I have 1 carbon and 1 oxygen, it's just carbon monoxide. If I have 1 nitrogen and 1 oxygen, it's nitrogen monoxide. But if I have, say, 2 nitrogens and 1 oxygen, now I have more than one of my first element. So I do need to use the prefix, so that's where I get that dinitrogen monoxide from. Okay? So let's try some. We're going to first take some formulas and see if we can figure out the names there. So here I have a nitrogen and 3 iodines. So I would get nitrogen, triiodide. Okay. Next I have a bromine and 5 chlorines. So bromine, pentachloride. Okay. Now I have 2 nitrogens and 4 fluorines. So I would get dinitrogen, tetrafluoride. Okay. So before you watch the rest of the video and get the answer to these other 3, I want you to pause the video and see if you can figure out the answer to these other 3 before I give you the answer to them. All right, let's see how you did. So here you should get sulfur trioxide. Here should be diiodine. Pentoxide. And the last one should be xenon sorry. I had an old example that was F6. This one's F4. So this is xenon tetrafluoride. I think my hand rested on the wrong color. There we go. Okay. All right, so those are the answers to this set. All right, now we have to be able to go back the other way. We also need to be able to take our names and figure out what the formulas are. Okay, so here's a few. So chlorine monoxide, so there's no prefix on that first element, so there's just one of them. We've got the prefix on the second element, so there's also only one of those. So chlorine monoxide is a ClO. Okay, carbon tetrabromide, we have CBr4. Okay, there's that hexa. So xenon hexafluoride. Okay, so same thing. Pause, see if you can figure out the other three, and then unpause the video. All right, so diboron, tetrachloride, so B2Cl4, diphosphorus pentasulfide, so P2S5, and then tetraphosphorus triselenide would be P4Se3. Now, one thing to notice is that in all of my names, whether they're typed or the ones that I wrote, okay, chemical names are not proper nouns. Therefore, don't capitalize. Okay, so we don't capitalize our chemical names because they're not proper nouns, so they're all lowercase. All right, so that's all there is to our binary covalent nomenclature. So this one's the easiest one. That's just this little isolated thing. You've got your nonmetals together. There's nothing to charge balance, and so we have to use these prefixes. Otherwise, we don't know how many of each element there are in the formula. Okay, so binary covalent. We're done with this one.